We're gonna walk through PyType really quick. We just found out about PyType. This is a kind of a neat technology where a simple Python package you can install through pip that checks and infers the types of your Python code. If you've TypeScript and things like that, you would annotate, or any other language like Java, for example. C Sharp. You've got there's others. There's others, right? So you got TypeScript, C Sharp, Java, and Golang, right? There's another one. They all have types on them where you can say when you define a variable, you say what kind of variable it is, what kind of data that variable is going to have. Is it a string? Is it a number? Is it an array? Is it an object? Or, those sorts of things. This PyType is really cool because it does type checking without requiring type annotations. And it does this through inferencing based on the literals that are defined when you assign your variable. So at assign time, the first assignment, the PyType will sort of lint your Python code, lint your plain, ordinary, unannotated Python code, and it will give you the ability to track that as a sort of a fact. Like the first time that you use this variable, it has a type of string, and if you ever try to manipulate it or munge it with other kinds of data where it will require coercion, which means that there has to be some sort of transition or casting that can occur automatically, right? Type coercion is implicit conversion of data types from one type to another, like a number into a string. You can represent a number inside of a string really easily like this, right? Let's give you, for example. So let's open up our text editor here. So like you can have, you can represent A is like hello is a string, and then B is a number 1, 2, 3. You can also have C equals a number 1, 2, 3, right? So you've got the integer version, and then you've got the string version. And if you do B plus C, that is type coercion. And probably what's going to happen? I don't know. It could be, you could be getting something like 1, 2, 3, 1, 2, 3, right? Where it'll concatenate the string. Or would it be, I'm actually kind of curious to see what Python would do. Let's open up a Python REPL here really quick. So what do you think it's going to do? Will it be this? Or will it add, like it'll be, 6, 4, it's like 2 and 4. There we go. So it'll be one of these things. It's one of the two things. I don't know which one it's going to be, but it'll be one of the two things. I'm actually kind of curious to see what Python's going to do. So let's get this. Let me pop this open here. Let's grab some of these variables and then push them in. Hey, Lorax, how's it going? We're just testing out some PyType really quick. This will be a short, quick stream, and then we are going to be back later today. Because I've got there's some meetings that are happening in the middle, but I really wanted to try. I'm actually really curious to see what is going to happen. So we see here on the screen, I'm really curious if we try to do B plus C, what is it going to do? Is it going to be this one where it concatenates the string used with type coercion, or is it going to type coerce to B plus C? It's going to be one of the two, right? We don't know which one's going to be. I don't know. Until we try it out. So I'm actually curious. Here we go. All right. What's it going to be? What's it going to be? Oh, wait. Oh, it already doesn't want to do that. It already won't let me. It already knows that it's not a welcome. It's not welcome. So if I think we did something like this, int, then it will work. Then we get 1, 2, 4, 6. Or we could do str, and then it'll do 1, 2, 3. Okay. So I guess, so then what's PyType going to help us with? I don't know. Because the example here that I was reading earlier was when you return two different data types and you try to coerce them through data coercion, like a string and a number, it's going to give you a lint error, which is totally fine. I guess, you know what? Here's where the value is. I understand now. I understand where the value is. The value is with PyType that this is runtime interpolation. And without linting with PyType, you won't know if there's going to be an error or a problem. So the code will compile in Python, but until you reach this point, you won't know whether it's a problem or not. So what we can do is let's follow this in I think there's a pip install. Let's do that really quick. And I'm pretty sure I already pipped install it. I already pipped it, installed it. So let's do that really quick. Let's get this going. See here, close this window because we don't need it anymore. And then we'll pip install. And then now we'll have PyType on our system, and you can use it as a linting for our Python code, which is really powerful because it'll help prevent mistakes. This is one of the bigger places where you can make mistakes with accidents is through type coercion. Although I just tried it and it worked, it didn't let me do it, but it was at runtime. So maybe what we get is compile time or linting time before the program runs. Before the Python program runs, we will get a chance to get a forewarning. So while that installs, there is an example here that it's going to give me a try. It's going to just let me try it out. Let's see, where was it? The def function. Def, where was it? Here we go. So we can copy and paste this. So we can see here that it's just going to return a string literal and a number literal. But G actually tries to concatenate or, use the plus sign. So let's find out here. Let's see here. Let's do that. Let's copy and paste this really quick. We're going to see PB paste. PB, let's actually go to the desktop really quick where I can just make a quick little folder, mkdir PyType, and then we'll go cd PyType, and then I'll PB paste test.py. There we go. Test. So we got our test, our data here, and now all I should be able to have to do is just run PyType. Let's see, I see PyTest. That's actually neat. What does PyTest do? Before we go into PyType, what does this do? What is this? What is PyTest? Is that going to, I don't know what that's going to do. Okay. Do I have PyType? Okay, so we have PyType here. What is this? What is this? I need that. I need more details about that. So what is PyTest? I'm comparing it to PyType. PyTest, only run test. Oh, okay. Some sort of a test framework, I guess, and with a whole bunch of options. All right, so this is different. This is for running unit tests, or that's my assumption for running unit tests. But PyType, let's check this out. Desktop, PyType. PyType, now we should be able to test our test file with PyType, and it will give us a lint error. And I'm actually kind of curious. So we know that's going to give us lint error because the documentation said it was going to. So it should. So it's going to open the file. It's going to read it. Let's see what it looks like here. So here's our file. Very simple. 2 functions. Uh-oh. I had some indentation errors there. Let's see. 1, 2, 3, 4. Here we go. 1, 2, 3, 4. Okay. Analyzing source with 0 local dependencies. Entering directory.pytype. Oh, cool. It even tells you where the problem is. Check it out. Error in G, unsupported operand type for the plus operator, string and ints unsupported. You could support it, though, if you had an add function with a double underscore. Then it would work fine on string, but it expects the current function for the add in the string expects a string. So that's actually kind of neat. That's really powerful. What happens if we just run it outright? Python test. Let's see what happens. Will it? Oh, well, it compiles fine. See, that's one of the problems is because you can. I think there's a Python. What is it? A Python compile command. What is that? I think just Python C maybe. Test.py, and it will just see if it compile. Let's see here. Actually, I need it. I don't think that's the right argument. Hey, 30 frames per second. Hey, how's it going? We're currently doing one thing really quick. We've got 10 minutes to go, and we're playing around with PyType because I want to see what PyType is all about. Type. PyType. PyType is infers your Python code without requiring type annotations, which is really cool. Python doesn't have typed variables. By default, it just does not have type variables. So you can make it just assumes automatically whatever your data types are based on the literals that are assigned to it. And so the really nifty thing with PyType is you can, it'll give you linting. It'll actually compile your Python, or I guess it intersects your Python code, and it will give you warnings, and it'll give you errors. Say, hey, this is a problem. Like you can't, like these two things. This is going to be a problem. So it's kind of neat. What we have here is we've got code in this H, and code in the H is going to be it'll work. So like if I just say Python, so it'll compile with Python. You won't notice that there's a problem. So I just run Python test and there's no errors, right? Because it's at runtime, the functions G, F, and H, we don't call them, but they are available to be called. And you might have hidden errors. This is why PyType is really powerful. So we can run PyType on our test of Py, and it's going to give us another error now, which is really cool. So it did find the first one where it says return F plus 2019. And it's going to also give us H, and it should give us, I'm actually kind of curious to see, because we're trying to do some weird stuff here. Okay, so it did immediately find the string. It found that one. Let's actually scroll up here so we can see. So it found two errors. It found the original error in the G function, right? The one here, up here at the top. And it found the new error, but it's still just string and numbers. What happens if we try to do something like this? I'm actually kind of curious. But before we do that, would regular Python even let you run that? 1.0 plus object. Yeah, see, it won't let you. Obviously, what would that even do? So let's. I'm actually really curious to see, is it going to give us an error on this H function now, or this H? Yeah, this H definition of a function. I think it will. I mean, it should, because clearly it didn't work. But I'm actually kind of disappointed that it didn't originally point out it up here. So like when we saw it, oh, okay. So it did see the error, and it knows. Okay, that's nice. So this is really cool. This is actually really beneficial. So before this, you can add this to your CI/CD and part of your maybe Git hooks or something like that. So before you commit any code, but we're playing around with PyType to see if we get any value from it. And we see some immediate value. It's actually kind of neat. But I did hear that in the GitHub repository that they were saying, let's see, is there Git? So we could say PyType GitHub. Oh, sorry, bro. No worries. Yeah, it's live. Yep, we are live. I did see here that in the README, because I was reading up a little bit before this. Okay, TLDR. We've got an update. We've got an update on PyType, and it is super useful, and I want to use it for my Python projects. The latest supported Python version for PyType will be 3.12. Okay, which is great. I'm actually kind of curious what version I've got locally. I might have 3.12. Python -- version. What am I running? 3.12. I'm running 3.12. We still are very actively interested in the space of Python type checking. But here's the thing. Here's the catcher. They're shifting investments towards new ideas and different frameworks. So this tells you that they might support, a little bit of PyType. Maybe they won't go beyond 3.12. Maybe it'll just stay at 3.12. Maybe PyType, obviously, is just statically analyzing the text. So it will probably work for most Python going forward into the future. Version 3, at least. It sounds like they're not going to support it anymore pretty much beyond that. But it's okay because Python's Python, right? Let's see if while PyType has been effective, its bytecode-based design has presented challenges in implementing new features. Faster adoption of new typing with Python's PEP, which is standard, like coding standard, like PEP, right? What does PEP stand for? I forgot. It's like Python. It's like a style guide. Okay, it's the style guide. Yeah, Python enhancement proposals. Oh, okay. Python. Okay, so it's sort of like RFCs, where you have different Python proposals and they number them numerically, and it looks like in incremental fashion. There you go. So there's pipe. Due to the bytecode inherent instability and propensity to change. Consequently, we intend to focus our investments on exploring new typing approaches that are better suited for Google's Python. and the users and make Python 3.12 the latest supported version for PyType. Okay, so they basically said 3.12 is, they're going to make sure it works, but going forward is probably not going to be anything that they're going to be investing in because they want to do something different. So it still sounds like we're going to have tools like PyType where they statically check our data types, but they're just going to do it differently. It sounds like they're starting the next version of it, which is great. It sounds like they're really excited about it. I'm wondering if there's is there anything else? Because obviously just trying to, what if here's one. I want to try this. So we've got A equals 1, but can we say A equals 2, right? And then A equals 3 in quotes. So we're changing the data type, right? So that could be a problem. That seems like a problem, right? So what I want to do is, there we go. Highlight. We're going to run this code. Let's run that code. All right. Let's see what happens. Obviously, when you run it with just Python, it's going to be fine. It'll have no problem. And then you say print A, and it will give us the string. It's a string. Perfectly fine. But if we run PyType on test, what's it going to do? It's going to complain, right? Because we've changed our data type. So this is one of the things. Like, this is one way to protect your code. Obviously, any other type languages would heavily complain and not work. Wait, it allowed me to do it. I wonder if there's like a different level of like a different, like some sort of configuration, like a dot here, something like this. Like if there's a YAML file. So PyProject TOML. Okay, to set up PyType on an entire package, add the following PyPackage TOML file to the directory immediately above the package. Replace the package. See if we've got 30 seconds left. Wait, I gotta go. Let's see here. So let's do pb paste. Actually, let's copy this. Oh, package name. Okay. Is there any other GitHub projects? See, what I want to do is I want to make it more strict. Like I want it. I don't want any changes in. Like I don't want this to be allowed. Like this shouldn't be allowed. I feel like if we're doing type checking here, and we change a data type with a variable, it shouldn't be allowed. PyType generate config. Oh, cool. Let's just run that. Let's do that. See real quick. And boom. All right. And then let's see. Inputs foo space separated list of files or directories to process. Okay. Version. Disable attribute error. Space separated list of error names to ignore. But I want it to be more strict. I want a strict mode. I want to go strict mode. Config. Okay. Interesting. Subtools. Merge Py. Well, guess what? We ran out of time. I'm actually kind of curious to see what it created. PyType. Oh, neat. Oh, look at that. It gives us a nice little setup here. That's pretty cool. Python version 3.12. No, none is not bool. Okay. Oh, cool. Strict binding. Yes, here, variables initiated as none retain their none binding. Strict none binding. Okay. I'm running late now. We're running late. I gotta go. But I'm actually really curious about this. Let's see. Let's just run PyType really quick. One last time on our test file and see if it complains now that we've specified our config. We might have to. No, it probably automatically knows because. Oh, see, it still doesn't. Leaving directory PyType, entering directory PyType. No work to do. Interesting. Well, maybe I'll play with it a little bit later to see if we can get something like this to be caught with the linter.